Attenuator is a two-port microwave passive device which is used to control power levels in a microsystem by partially absorbing the transmitted microwave signal. So, as you know, the attenuator is a type of device which attenuates the signal. So, attenuation may say that the attenuation of a signal will occur only when there is some percentage of signal absorbed whenever the signal travels from one point to the other. The same thing happens in a microwave attenuator also. But the absorption of the signal, that is the partial absorption of the signal, will take place depending upon the type of material that is implemented or is that is connected in the path of the transmission of the signal. So we can define an attenuator is a two-port microwave passive device which are used to control the power levels in a microwave system, and that is done by partially absorbing the transmitted microwave signal. So the types of microwave attenuators. There are two types of microwave attenuators. One is the fixed attenuator and the other one is variable attenuator. A fixed attenuator is an attenuator where the level of attenuation is fixed. Means, for example, if you are giving an input power which is about 20 watts. If you are giving an input power, let me take an example that you are giving an input power of about 10 kilowatts, or else if you want to talk in terms of dB, if I am giving an input of 40 dB, then the output would be fixed percentage. Means if in a fixed attenuator, if I want to attenuate a power of about 2 dB of about 2 kilowatts, then the remaining power that is transmitted to the receiver is 8 kilowatts. The same if you want to express in terms of dB, if I take a consideration that there should be 10 dB of loss in the power, then 30 dB, the remaining 30 dB should be transmitted at the end. So here the level of attenuation is fixed. Means whether I want to attenuate only 2 dB or is whether I want to attenuate 5 dB, it is fixed. I cannot vary. So once you transmit a microwave signal through the fixed attenuator, then whatever the level has been fixed, that percentage of the signal is get absorbed. Suppose for example, let me take an example where you are given an input power of 20 dB. And if you transmit the signal of 20 dB in a attenuator which is designed for 5 dB, then the output power what I obtain is only 15 dB. So this is what an fixed attenuator is. A fixed attenuator is a level is a attenuator where the level of attenuation is fixed. Next, coming for variable attenuator. And variable attenuator is a type of attenuator in which the level of attenuation can be varied. It is not fixed. I can vary 5 dB, I can attenuate a level of 10 dB. In accordance to the requirement of the application, I can vary the attenuation level. Those type of attenuators are called as variable type of attenuators. Okay. So there are two types of attenuators. One is the fixed type of attenuator and the other one is variable type of attenuator. Fixed attenuator is a type of attenuator where the level of attenuation is fixed, and whereas a variable attenuator is attenuator where the attenuation level can be varied in accordance to the requirement. Next, fixed attenuator. So here is the diagram of a fixed attenuator, which is a coaxial line fixed attenuator. In fixed attenuator, we have only one type of attenuator. Okay, so the fixed type of attenuator is a coaxial fixed line attenuator. So this is the diagram of the coaxial fixed line attenuator. This is a coaxial line. This is a coaxial line where It is a microwave type of structure. And this is the inner conductor. As we all know, the inner conductor is the one which allows the signal to propagate. What we do in the manufacture of attenuator is a lossy dielectric material, which is a tapered end material, is placed in the path of the signal propagation. So whenever this tapered material or a lossy dielectric material is kept in the path of transmission of the signal, then the signal will is absorbed by means by the tapered material, and only the remaining signal is transmitted to the output. And here we call this as a fixed attenuator because I cannot change the length of the lossy dielectric material which is placed in center conductor every time. Only whenever the fixed attenuator is manufactured, we fix the level of attenuation of what is the required level of attenuation that has to take place, and that particular design is done at once. That's the reason why we call this as fixed attenuator. So here is diagram of a coaxial fixed line attenuator which uses a dielectric lossy material inside the center conductor of the coaxial line, and this lossy material will absorb the power whichever is transmitting in the center conductor. Okay, and the power whichever is not absorbed by this material, the remaining power will is delivered to the output port. Okay, so this is the fixed attenuator. Next, coming for variable attenuator. An attenuator in which the level of attenuation can be varied is called a variable attenuator. This is what I told. So there are three types of variable attenuators. They are movable vane type of attenuator, the flap type of attenuator, and the precision type variable attenuator. Okay, so there are three types of variable attenuators, that is movable vane type of attenuator, flap type of attenuator, and precision type of variable attenuator. And all these three are called variable attenuators because we can change the level of attenuation in accordance to requirement. Let us study the first one in this. That is the movable vane type of attenuator, or is the movable vane type attenuator. So this is the movable type vane attenuator where this is called as the input port. So an attenuator is a two-port device. Okay, it has only one input port on one output port. So they are the two ports. One is input and the other one is output. So, and it is a rectangular waveguide structure. So a mobile vane type attenuator is a rectangular waveguide structure which has two ports, that is input port and output port. And there is a lossy dielectric material, or lossy material which is placed in the path of the propagation. So this is the lossy dielectric material which is movable. Okay, so here the lossy dielectric material is placed in the waveguide, which is a dielectric slab that is coated with aqueduct, which is placed at the center of the waveguide, which is parallel to the maximum E field. And here the induced current on the lossy material due to the incoming microwave signal results in power dissipation. Indirectly, it leads to the attenuation of the signal. And here there is one more important parameter to be noticed. Normally, the dielectric slab which we are keeping is tapered at both the ends, because depending upon the length of the wavelength of the signal reflections, the power can be varied, or as the level of attenuation can be varied. That's why we have a tapered end of the lossy dielectric material. So just a simple schematic, let me try to explain you. This is the rectangular waveguide structure where this is the input port and this is the output port. This is the waveguide structure. And in the path of transmission, this is a tapered resistor card which is placed. And it is called as variable. The main reason is this tapered resistor card will be attached to a knob where the knob can be rotated in clockwise and anti-clockwise direction. Whenever the knob is rotated in clockwise direction, the resistive film moves inwards. In the same way, whenever you move the knob in the anti-clockwise direction, the resistive film comes outward. Okay, inward and outward. Whenever this resistive film goes inward, then maximum power is absorbed. Whenever the resistive film or the tapered resistive film is moved backward, that is, the knob is rotated in the anti-clockwise, then during that time the vane returns outside. During that time, less percentage of attenuation will take place. Lesser attenuation will take place. That's why this is called as a variable type of attenuator. So, I have the diagram of that, which was also shown in the earlier classes, but once again, I'll just show it as a reference for you. So, this is the attenuator. See, you can see that it is a variable type of attenuator. So, in this, the rectangular waveguide structure is there. And in this rectangular waveguide structure, which is there on the top, and the knob at the bottom, that is there's a meter reading 5, 10 like that, right? So that is the meter knob. That meter knob is attached to a rotary type of disc, and whenever I rotate this knob, then the flip or as the vane can move inside and backside. Move in forward direction and backward direction. Whenever it is rotated in clockwise, it moves in inward direction, and whenever it is rotated in anti-clockwise direction, it moves back in outward position. So depending upon the inward and outward position, the level of attenuation can be varied. Okay, so this is the type of variable attenuator which will be using your communication systems lab to conduct the microwave test bench experiment. Okay. So the same thing is the device, that is movable vane type attenuator. And coming for the second type of variable attenuator, which is the flap type of attenuator or as flap attenuator. The name for this is given as a flap due to the reason that there will be a flap which is implemented on the waveguide structure, and depending upon the movement of this flap structure, the level of attenuation will vary. Like for example, if I take the example of your classroom or as any one of the room which has about 4 windows, if I just open any 2 windows, the level of breeze that comes inside your room is is comparatively 50%. But if you open all the 4 windows of your room, then the level of breeze, the percentage of air that whichever is entering your room is more. You feel it, right? So in the same way, here also it's the same. It is implemented on the same concept, which is a flap type of attenuator. A flap is used where depending upon the input or its connectivity of the flap or its level of insertion of the flap, the percentage of attenuation can be varied, or is the percentage of attenuation is varied. So that is what we call it as a flap attenuator. So this is the diagram of a flap attenuator. This is a rectangular waveguide structure. This is input port and this is output port. No, he has taken the other way. This is input and this is the output port. So whenever the signal enters from a microwave device or as from a microwave source to into the attenuator, then here this is the flip which is movable and this flip will be inserted inside this hollow structure, inside this structure. So depending upon how much percentage the flip has been closed or as how much percentage the flip has been closed, depending upon that, the attenuation will take place and only the remaining signal goes to the output terminal or as remaining signal goes to the output port. Okay, so this is how the variable of attenuation is obtained in a flap type of attenuator. Okay, and whenever this flap is completely outside the slot, there is no attenuation at all. Means so this is a flap. This is a flap which we have. That is, this is a flap. If it is just completely kept open, there is no attenuation obtained. Means take the same example where in your room you have there are be 4 windows and if you keep all the 4 windows open, then the maximum air enters your room. So at that time, the level of attenuation of the entry of air is 0. Here also, in this case, it's the same. Whenever this flap is completely open, there is no interruption in the transmission of the signal. So, whatever the signal that enters the input port, that comes out of the output port. Okay. And in the same way, whenever I just move this flap up to some percentage, it is something like closing of the transmission of the signal. Okay, and during that time the signal gets absorbed and which results in attenuation of the power. Okay, and whenever the flip is entirely closed, then the attenuation is maximum. Means suppose if you take an example where all the 4 windows of your room is completely closed, then you can feel that there's no breeze entering your room. So maximum attenuation of the outside signal or as maximum attenuation of the air when you are closing all the 4 windows. Okay, so this is about the flap type of attenuator.